Well, another Monday is here, and I thought I'd run you guys through a little bit of stuff about catalytic converters and spark and fuel systems and that kind of thing. And usually I can mix a few little stories in here that I forgot to tell at some point, or I may have already told. But anyway, my wife knows what kind of a storyteller I am, because she gets to hear a lot of my stories. But anyway, this is just a few catalyst, spark, and fuel trim tips. To begin with, a healthy catalyst is going to store enough oxygen to make the necessary changes in the exhaust stream so that the CO2 is high and everything else is low. That's basically what you're looking for whenever you're doing a exhaust system analysis. Back when I worked at the Volkswagen place in the early 80s, we used to have to hook an exhaust gas analyzer to the a little port on the exhaust, and exhaust down there, and we would it was a little, we slid a hose over it, and there was a little pump going through there, and we would adjust through this machine, and we would adjust the airflow meter so that the CO was at 1.0, and that was way back in the early 80s. Those old Volkswagens had a cage electronic fuel system with a fuel distributor and a frequency valve and an auxiliary air regulator and all that kind of stuff on them. Real interesting system. But the long and the short of it is that CO has always been, that was the standard by which we adjusted that meter. That was the point. Okay, and so the code P0421 may mean that one or more of the following is happening. The catalytic converter is not functioning properly, an oxygen sensor is not reading or functioning properly, or a spark plug is fouled. Now sometimes the catalyst will get contaminated and not read right, and you can actually take measures to burn that off of there, but that's another story. But there's your P0421 code. Warm-up cat. The warm-up cat's the one that's closest to the engine. You might notice that on a lot of your four-cylinder cars now, they're putting the catalytic converter right there as part of the manifold. And since EGR comes out of that mix, on some of your Altimas and stuff, when the catalytic converter comes apart in there, it will actually pull chunks of rock in there and destroy the engine. I'm talking about the pieces of rock from the catalytic converter. Catalytic converters were a strange thing. I may do a whole presentation on those, on the development of them and everything. But to start with, it was really spooky for the automakers when they found out they were going to have to put catalytic converters on there to meet emission standards, because they didn't think that anybody could produce catalytic converters fast enough in order to satisfy the demand for the automotive industry. But that turned out not to be the case. Now this is what you're basically looking at. If you see an oxygen sensor on the rear oxygen sensor and the front oxygen sensor are more or less switching together, sometimes you'll basically see an oxygen sensor that's in the rear. I'm talking about the catalyst monitor. That showed up on the OBD2 systems. There was no oxygen sensor behind the catalytic converter on OBD1, but OBD2 required the catalyst efficiency to be measured, but it's only measuring, in most cases, the warm-up cat, which is the one in the front. Now, the old freeway catalyst, and you'll see that on your little VEC ID calendar of the hood, the three-way catalyst handles carbon monoxide, hydrocarbons, and oxides of nitrogen. It handles them all three. The warm-up cat is what handles the oxides of nitrogen, and then the one behind that typically always handles the hydrocarbons and the carbon monoxide. Now, carbon monoxide and hydrocarbons are close to the same thing, only hydrocarbons is just straight carbon molecules. Carbon monoxide comes from a rich mixture where there was more fuel than there was air, and so every carbon molecule wants to get married to two oxygen molecules to make carbon dioxide, but if the mix is too rich, there's not enough oxygen molecules to go around, and there's only one molecule of carbon with this, it would be CO instead of CO2. That's an odorless, colorless gas that you can't smell and you can't see, but it will kill you. It's really important. That's what people kill themselves with when they crank their car in the garage. All right, so this one here, there was a probe that I worked on in a Mazda that I saw later with the same problem that threw a P0421 code. And when I was working at the dealer, I would basically do the troubleshooting, and if something like a catalytic converter needed to be replaced, they would put it on the line where the line mechanic would replace it. And so I saw a P0421, I went in there and looked at the scan tool, and I saw that the oxygen sensors were switching together, it was still under warranty. And so I took I went into the parts room and I ordered a catalytic converter. They didn't ask me which one I wanted. They just basically looked in their parts book and they ordered this one right here. Well, there's no oxygen sensor behind that one, so that's not the one that was throwing the code. But after that was put on there by the line mechanic, the car came back with the same code, and it turned out he should have replaced the one right there at the manifold. All right, so and that's where that is. It's right here. They put it really close so it'll get really good and hot, and it's got an oxygen sensor above it and below it. That's how you know that that's the warm-up cat. It's basically that your PO421 is talking about. And so this one here is the one farther back, see, on that particular system. There's your warm-up three-way catalytic converter. Well, of course, I say it's not, this is going to be the second part of the catalyst, and that's the first part that handles your oxide and nitrogen. Typically, at least that's what I was taught a long time ago. EGR valve, you know, is going to be for your, you remember what the EGR valve is for? EGR valve takes care of oxides of nitrogen as much as it can by putting inert gas in there to cool the mix down a little bit so it doesn't go above 2,500 degrees during the combustion process. And while the PO421 won't typically affect engine power, the rear O2 signals can affect fuel trim. A lot of people don't know that. The whole programming that's written on these things nowadays is to keep the catalytic converter happy. If that engine controller discovers that it cannot trust the front oxygen sensor, it will ignore that one and start handling fuel control based on that rear oxygen sensor. So be perfectly aware of the fact that your you know, if your front one's gone dark, your fuel trim can be affected by that rear one. And that's about all I'm going to say about that. Be careful when condemning a catalytic converter for loss of power, because not all tests are reliable. Let me talk about good tests. But first, let's look at oxygen sensors. On your Chevy and your Dodge, the cylinder that's closest to the front, which that would be the rod that's on the front of the crankshaft journal, the farthest forward rod, is number one on the driver's side on a Chevy and a Dodge. And that's going to be bank 1 is where oxygen sensor HO2S11 is located. Bank 2 is 2-1. Now that's the way it is with Chevy and Dodge. Notice the Ford's different. Bank 1 is on this side, so oxygen sensor HO2S11 is on that side. And 2-1 is over here. I just drew this on paint this morning and I put it on my Technical Writer Facebook page. Anyway, make sure you're working on the correct side. Whenever they first came out in '94, these oxygen sensors, you know, there were 4 of them. I was confused about what was 1-1 and 2-1. You know, in my mind, I thought this should be 1-1 and that should be 1-2. And this should be 2-2. Anyway, I got all screwed up and I worked for an hour on the wrong oxygen sensor before I realized I was looking at the numbers wrong. Just make sure you understand this. Now, when the engine's in there sideways, it's a little trickier. But suffice to say, you need to know which bank is bank 1, and that'll be where number 1 cylinder is, and that's where HO2S11 is, and HO2S12. And then the other side for bank 2. All right. What was the first emission control device ever used on a passenger car in the United States? Catalytic converter, EGR valve, carbon canister, or PCV valve? Do you know? All right, I'll tell you what it was. It was the PCV valve, and if you recognize that, that is a Corvair. The Chevrolet Corvair had the first emission control device, at least by the stuff that I've read and studied. And the PCV valve was right here. It was an inline PCV valve. You see that hose coming out of there? And it was basically pulling vacuum out of the crankcase all the time to do away with the blowback. Before PCV valves, there was a draft tube that was cut at an angle, so when you were driving down the road it created low pressure and it pulled crankcase back pressure out of the crankcase, but it put it out into the air. And in these big cities it was terrible. Those police officers had an awful time with that, you know, burning their eyes and all that kind of stuff while they were directing traffic, and a lot of them did that back then. But the PCV valve was the very first thing they did to reduce vehicle emissions. If somebody knows something I don't know, send me a message. You know, I'm not one of those people that claims I know everything, but I did find this out from a very reputable source a long time ago, and that's what I've been teaching. Now, this was me doing a temperature gun check on a vehicle, and I don't remember what kind of vehicle it was, but you can see this can be kind of confusing here when you're checking these, because sometimes they're hotter than others. Up here at the top, you're at 394 degrees. Now, or if you do a temperature check and you're using a temperature gun to try to determine if the catalytic converter is bad, I'm going to be honest with you, that is not a reliable test. This one here is hotter right there where it's coming out of the engine because it's supposed to be, because that's where, you know, the exhaust is the hottest coming right out of the cylinders. And that helps the warm-up cat get hot that much quicker. That's why they put it so close up there. And so if you're saying, well, I've got a catalytic converter that's hotter on the inlet than it is the outlet, that doesn't work on the one that's mounted right there on the front of the engine like that. So you can't go by that on that. I've actually seen it fail on the other kind too. Wouldn't you expect the exhaust to be hotter right where it's leaving the head? Well, yeah. With the logic of warm-up cat testing goes like that. Now see, this is really hot, and this is hotter, and that's supposed to be even hotter, technically. But because of the fact that you're so close to that, you're typically going to measure more heat right here than you are right there, even on one that's working right, if it's set up like this. But the temperature reading, the wisdom goes, from the outgoing gases should be a good bit higher because of the chemical reaction happening inside the catalytic converter. If the catalyst is partially plugged, the engine side of the converter will be hotter or the same temp as the incoming reading. Now this is from Walker. This is pretty good information here from Walker Muffler Company. If the rear weld ring is significantly cooler than the front, the converter may not be lighting off. It's got to light off to start that chemical reaction on the inside, and there's heat there. This may indicate the converter has failed or the exhaust mixture is not correct, the symptom of underlying emissions issue. So converter temperatures won't usually exceed 1200 RPM on a properly running engine. The ones on my Explorer usually run about 1300 driving down the road. Periodic operation above 1600 can negatively affect the precious metals coating of the clay substrate on the inside and make it less efficient. Excessive temperatures can reduce the converter's durability or, if high enough, destroy the converter's matting or substrate, and that does happen. Damaged matting and melted substrates typically occur at temperatures exceeding 1700 degrees. Too hot is bad. That one there is glowing red hot. And just about everybody that's done much work on a vehicle and has had a fuel system issue going on has seen that happen. Long time ago, at the gas station in the 70s, there was a Camaro or something we were working on in there. Heck, I don't remember what it was. But anyway, whenever you would crank it up, it didn't have a catalytic converter. That one didn't, because this one was pre-catalytic converter, which those came out in about 72. Anyway, this was like a late 60s Camaro with a 350 in it. And that darn thing would the muffler would get so hot that it would smoke the carpet on the inside of the car. I mean, this was a red hot muffler. And it turned out that that one had a vacuum leak. Now, I've always tried to parse that in my mind and figure out why a vacuum leak made the muffler get so hot, but I'll just leave that right there. But that was a true story. Most contemporary engines require spark plug replacement every how far? 50, 60, 80, or 100. Most of them nowadays are 100,000 mile spark plug replacement. And I've seen, you know, I told on one of these things about an Explorer that I saw that was still running really good. It was an 08 Explorer. They had 280,000 miles on the original spark plugs. The reason I knew they were original is still had the paint spot on the top, and they still have the original old Motorcraft number. And I was familiar with that because I worked at the Ford place and those things were new. But it's totally amazing sometimes how spark plugs would go. Even with the old copper spark plugs, back in the day, I've seen those things go 100,000 miles and still be running good. Back on the old 302, like 80 or whatever. A bronze blue rainbow discoloration of the shell typically indicates elevated temperatures. If the converter is removed, look through the substrate to observe to see if the small passageways are melted, collapsed, or clogged. Alright, so I'll put it this way. If the cat fails a temperature gun test, hotter at the inlet than it is at the outlet, see, this is what the numbers you're pretty much looking for, then it's a lot more certain than if it passes the temperature gun test. You can pass this test and still have a bad converter, and I have seen this on more than one occasion. A vacuum gauge test didn't produce a smoking gun evidence on this Monte Carlo we worked on. If vacuum stays low on an unloaded engine with the throttle open, it points to an exhaust problem. And you know, the rev limiter on this whole thing was only about 4,000 RPM if you were revving it up without a load. And that's what it was bouncing on for us. Drawing on the muffler shop method, we drilled a 1/8 hole right in front of the converter, used a cheap fuel pump pressure vacuum gauge, and we found this. It would run 45 miles an hour top speed. By the way, it had passed the temperature gun test. We had 200 going in and 440 coming out. Well, that didn't exonerate it. Hold on a second, I'm going to show you the readings we got. Test question 3 is first. This reading, 200 ohms, measuring the center electrode, is too high, too low, just right, unnecessary. This is a funny story here. This is from Ford's Advanced Engine Performance course that I took that picture down at the training center in Tallahassee. They were saying to measure that, and if it's got less than 8,000 ohms, you're okay. Usually I read 4,000 to 6,000 ohms, and they all read pretty much the same. Anyway, this one here, that was a misfire. I read 200 ohms there, and in that case, I typically put a spark plug and a coil in it, unless if it's all if it was low mileage. Now, if it's higher mileage, you want to put all the boots and whatever coils you feel like are bad, plus spark plugs in there. But anyway, that's just a little thing. With this piece of high temp hose held up to that small hole we drilled, that's the 1/8 hole he's holding that up to in front of the catalytic converter. We found the pressure between the engine and the cat pegged our gauge all the way down to that. Now that's back pressure. Had we stopped with the temperature test, we wouldn't have found this so quickly. We put the catalytic converter on it and took care of this problem. It was clogged up. That vermiculite stuff had got the little wrapping around the outside and started coming loose and getting in there and clogging it up. Even 5 pounds of pressure is too much. And I worked on over at the school, we worked on a doggone Trailblazer. And the guy said it just didn't seem like it had the power it used to have. And so I took one of these little 18 millimeter plugs, that's 18 millimeter spark plug thread, by the way, and I drilled a hole through it and I put a brake bleeder valve in there. And I made myself a tester so I could pull an oxygen sensor out, put a hose on it with a high temperature hose. You need to put high temperature hose on there because it'll melt a rubber hose and cook it in a flash. But anyway, put that hose on there, brought it up, and we had 5 psi of pressure. 5 psi of back pressure in front of the catalyst is too much. It should not be even 1 pound of pressure. If it's got more than 1 pound of pressure, then chances are you got catalyst issues. Then a remote, every now and then you may find a muffler stocked up or something like that. But if this was 5 psi, and on that particular Trailblazer, when we pulled it off and looked in that converter, it was stopped up almost as bad as the one I showed you in the previous picture. Summit Performance sells these O2 sensor hole plugs for $6. You can actually, when you buy a new catalytic converter, sometimes it'll have one of these plugs in there, and you can screw that thing out and hang on to it. Don't throw those away. You can make a tool out of that. You don't have to buy an expensive tool for measuring exhaust back pressure. It's not necessary. If the cat's clogged, you might remember the story about the Merkur XR4 Ti that my buddy was working on over there, and he came to me and he says, this thing's got spark, it's got fuel, it's got compression, it's in time. He said it won't start, I don't know why, it's driving me up the wall. And I said, pull half the spark plugs out. So we pulled 3 of the plugs out, it was V6, and it fired up. And he said, what the heck does that mean? I said, well, it means the exhaust is stopped up. And I don't even remember where I learned that or how I figured it out. But one, if you pull half the plugs out, it'll start up, and you got the other, and it won't start with all of them in there. Look at an exhaust problem. It'll sound like a machine gun blowing out the holes that the spark plugs are moved out of. But anyway, that's why I tell war stories. What kind of vehicle is this? Do you recognize this? All right, look at that word right there. Now, if you're somebody that's worked on a lot of different vehicles, you'll recognize that word because that's only one make that uses that word. This is a Chrysler. It's actually a Jeep. All right. As for loss of power, there was a time whenever I was probably 22 years old or something like that, 23, down in Sabine Pass when I was working down there at the Offshore Services Company. And we had a car like this one that you see behind me right here. And that thing went to, the guy that was driving it drove up to, was going his way to Colorado. And he started having trouble. The car would start slowing down, and quit. And then he would let it cool off a little bit and then crank up and then go again for a ways. And he limped into the parking lot at Love Field, Dallas Love Field Airport, and he flew the rest of the way to Colorado. And the vice president of the company says, what are we going to do about this? And I said, well, let me grab some parts and tools and everything, and I'll fly up there and fix it and drive it back. Now, this was back when there weren't any cell phones. I didn't have no way to contact anybody except for a payphone I might find somewhere. And, this was back in like 80 or 81. But anyway, I drove up there, and I got to the airport, and I found that car, and it cranked up just fine. I drove it down the interstate coming from Dallas down to headed toward Houston, And I got about 100 miles out of Dallas and it started losing power. And I said, that feels like that's starving for fuel to me. And so I coasted over beside the road and I got out and I took the fuel pump line loose from the fuel pump, which had a mechanical fuel pump, and I blew backwards through it and I could tell it was completely clogged. And I let it sit there a little bit, and then I drove a little farther until I could find an exit, and I went to a gas station and I asked that guy if I could borrow his air blower, and he said I could. And so I pulled up there close to his shop and I took the gas cap off, pulled that hose off, and stuck the air blower to that hose going back to the gas tank, and I shot some air in there and a bunch of gas shot out the filler neck. But that cleared that thing up and I drove it the rest of the way back home. Didn't even have to buy any parts. Well, the problem was we had a big tank similar to this, except it was vertical, where we got the gas out of there. And that tank had been built by the welders and it wasn't coated with anything on the inside, so it had all kinds of rust in there. And when we were putting gas in these vehicles, they would keep putting rust and putting rust and putting rust until there was enough to clog up the sock in there. The sock on the fuel pump, the fuel pickup, which it didn't have a fuel pump, but the fuel pump was on the motor. Anyway, that took care of that problem there. I had to clean the gas tank out and clean off the sock and all that. That's what was wrong with that one. He thought there was something electronic wrong with it. Some farms have homemade gas tanks today, and farmer wife may put some fuel in there, and that's what happens there. That rust is so fine and such, those iron oxide particles can be so tiny and so small, they can go through a fuel filter and stop up an injector, the fuel pressure regulator. On some of these expeditions, you can take it apart and you find all that rusty crud in there like that. That came out of that tank. Well, the injectors will clog up too, and it's hard to get that rust out of there. Replacing the injector is kind of expensive, unless you buy a set of them on Amazon or something. But the long and short of it is, just be aware that there's not a fuel filter that I know of that will stop rust that comes out of a tank if they're pumping it out on the farm. Just be aware of that. That stuff right there, the inside of that injector will clog up, and you'll have a no start. It'll come in from that way. Question test 5. What's the purpose of this relay? This relay right here, auto shutdown. Does it shut the engine down, feed the injector's coil and the alternator, provides power to the crank sensor, delivers reference voltage to DP? This is the right answer. Feeds the injectors, the coil, and the alternator. This right here is vaguely similar to the e-power relay on a Ford, except on a Ford, the e-power relay does not feed the coil. On a Ford, the coil is fed by the ignition switch. All right. So some flex fuel vehicle systems, they use a flex fuel composition sensor. You buy this darn thing from your Chevrolet dealer, you're going to pay $750 or $800 for it. But you can buy one that's the it's the Delco brand off Amazon for like $350. We had one that was a hard starting car. Sometimes it would start really, really hard. It was a 04 model Tahoe, and whenever we caught it in the act, we pulled the plugs out and they were soaking wet. And so I got to looking through the PIDs and I found out this thing was reporting 45% alcohol in the fuel. It was a flex fuel vehicle. I called the lady up. I says, does he use alcohol fuel in this? She goes, no. He never uses anything but regular gas in there. And so 45% alcohol is 35% more than it ought to have, even if he's using that E10 stuff. So I says, okay, let's go ahead and I measured the hertz. I don't remember what the hertz reading was, but I figured out that this what was wrong with it. We popped one of those things on there, and that took care of that whole problem. And that's an expensive rig. They have other ones too. That's a Continental fuel composition sensor. Whenever the Ford ones first came out on Tauruses back in around the turn of the century, those darn things were $3,000 or something. It was stupid money. And then Ford actually wound up going, they started using the oxygen sensors and some programming to handle flex fuel stuff. Incidentally, flex fuel vehicles have got a better fuel pump. They got better fuel components. They got better gas tanks and all that, because alcohol is corrosive. So they had to make the gas tanks and the injectors and all that stuff higher quality to be able to withstand that alcohol fuel if people decided to use it. But if somebody pumps E85 into a regular car, you might do a test on that fuel. I think I've shown you how to do that on here before. If I hadn't, that may be later. But anyway, if you test the fuel, you may find 40 or 50% alcohol fuel in a vehicle that's not even set up to run E85. When I reach the point in the repair that I'm waiting on parts, I should use that time to do what? Play games on my phone, find something productive to do, head for Hardee's, ask for a promotion and a raise, whine, or cop an attitude. Basically, the right thing to do is find something productive to do. That's what I always did. When to get a fuel-injected engine started, the PCM must double pulse the injectors while cranking if it doesn't have one of those archaic old cold start injectors that used to be on some of the Asian cars. If that double pulse is not happening, you can have a hard start cold situation. Be aware of that and troubleshoot accordingly. A slightly weak spark in engines with only one coil and a distributor can cause hard cold starting. I saw an E-core ignition coil that would only jump the spark about 3/4 of an inch and only had about 50,000 volts max that it could produce. That was a hard start in Taurus. It would start, it ran just fine, but it was a hard start in Taurus. Took me a while to figure that one out. The spark needs to be able to jump, scare you to death. I mean, like an inch, just like blue lightning, and so that you're terrified of it. If it'll only jump about 1/2 of an inch and it's a sort of an orange color, or it's kind of weak, it's not going pop, pop, pop real loud, then you're going to have weak ignition coil issues, provided there's enough voltage feeding the coil. Just for grins, this is an injector opening right here. This is the current ramp. That's when the pintle opens on the injector, that little pintle hump. If you've got one of these, this current ramp, that doesn't have a pintle hump, that might mean your injector is not opening, so be aware of that if you're checking for a misfire. This is your 12 volts on the trigger side of the injector, pulls it to 0. When it releases it, you got about a 50 volt spike, then it levels off and is ready for the next time. But you notice it basically goes up here and it ramps up, and the amperage does, and that little pintle hump is very telling. When doing an oil change, I should get a cheater pipe and turn the drain plug clockwise so it turns round and round. Check the drain plug for distorted threads or a leaking gasket. Start the drain plug and walk away for a while. Lower the car halfway and rotate the tires while the oil is draining, or take a nap in the trunk. Well, I would be looking here. Distorted threads. If you start taking an oil drain plug out and it gets hard part of the way out, you got you some issues. You need to replace that oil drain plug. Typically, unless it's an aluminum oil pan, you won't usually have any issues with the threads in the oil pan unless somebody has put one of them self-tapping plugs back in there. That's a gasket that's stuck. You need to check that too. You don't start the drain plug and walk away. You don't lower the car halfway and rotate the tires. You may forget to put the oil drain plug back in, and that kind of thing happens. You don't take a nap in the trunk, obviously. This is one of the things you need to do. I had a whole jar full of drain plugs that we changed out. Drain plugs don't cost hardly anything. Just make sure you know you're getting the right one. All right. This right here was a weak spark on a Dodge that we checked, and this one right here, we actually hooked up an E-core ignition coil to that same vehicle and found a lot stronger spark, and that told us the coil was bad. And I have actually taken a Briggs & Stratton lawnmower coil and started my wife's Tempo with it when I was working on actually it was a go-kart. And the people at the place I went to get the points and all, he said, "How you know the coil's good?" I said, "Because I started it in my wife's car with it." He said, "How the heck did you do that?" A coil is a coil. I mean, you can fire one coil with another system, it works. It's just a component. When checking a no start, I should A, get stumped so the newspapers write about it, B, listen for the fuel pump, check for power at the injectors, and then check reference voltage. Check the fuel pressure only I can hear the pump running, do B and C, and then check for spark and injector pulse. I'd do these, and then I would check for spark and injector pulse. If you hear the pump running, then you know what? On a no start, if I hear the fuel pump kick on, I know the PCM is at least powered up and functioning. You don't know there's good fuel pressure. You don't have any way of knowing that unless you check it. And on those CSFI engines, those Chevrolets, if they don't have like 60 pounds of fuel pressure or more, they might not even operate those poppets. So if you got 58 pounds or 56 pounds of fuel pressure on a CSFI, you may be in trouble. Anyway, so if I hear the fuel pump and then I don't find I don't have injector pulse or spark, you're typically going to have a crank sensor problem. That's just the way it is. Well, that finishes up the video. Today I hope you got something out of this. I really enjoyed doing this. I feel like I'm talking to a bunch of old friends out there. And I appreciate the likes that people put on the videos. And I appreciate when you watch it all the way to the end. But there's an awful lot of stuff out there that's new, there's new rules, and finding the weak links in the chain and whatever product you're used to servicing, it will help you fix them faster. Get your scan tool and look at every PID that you possibly can on the ones you work on regularly so you'll recognize a bad one when you see it. knowing the good ones are what makes you be able to spot the bad ones. That's why Secret Service men study good money instead of bogus. We'll see you later.